Hey guys, welcome to my channel. Today we have a very good problem for you guys called Palindrome number 2. So it's a very good one, so make sure to pay close attention to the problem statement, right? So it says given a string s, right, return true if the string, right, can be a palindrome after deleting at most one character from it, right? So that's a very good problem statement, very simple and concise. So we're just giving a simple string and we need to find out if it's a palindrome or not, right? And if it is, then return true. If it's not, return false, right? But there's one thing to it, right? We can't afford to delete one character from it, right? So this is the thing that we need to worry about, guys, right? So this one is, like looking at it, right? It's a palindrome. So what's a palindrome, right? Before you get into it, guys, right? A string is a palindrome if it's read the same uh forward and backwards, guys, right? That's what a palindrome is, right? So a very famous example of the palindrome, guys, right? Example that people use all the time, guys, right? And I've used before in the past videos, right? Is race car, right? We could reading it forward, right? Race car, right? Then reading it backwards, race car as well, right? So it's read the same forward and backwards, guys, right? So it's a palindrome, right? And it's examples like shows it the same way, guys, right? ABA is the same as ABA as well, right? Return true, right? This one, right? ABC A, ACBA, you might be saying that it's not a palindrome, right? But guys, right, they said we can delete at most one character, right? So we can afford to delete one character. So we could read it ABA, right? Is it the same as ABA, which is the same example we have here, right? That's after we delete C, right? Or it could be ACA and ACA again, right? Which is this, right? ACA without, if we were to delete B, guys, right? So then it would be a palindrome because it's read the same forward and backwards, right? And this one is not a palindrome, no matter which way you want to put it, right? Because let's say we delete A, right? BC is not a palindrome, right? And to check this, let's say we delete B, right? AC is not a palindrome, right? So yeah. So as you can tell, right, there needs to be, every character needs to have like a matching uh character, right, to go with it, guys, right? For it to, unless it's like the middle element or something, right? Which is another case itself, right? So you can see this example is the same way, right? Every character has a matching on the other side, right? Okay. So you see, for it to be palindrome, right? The first element, the last element needs to be the same. The second element and the second to last element needs to be the same. The third element and the third element to third from the last, right? Third last element needs to be the same as well, right? And then the middle can be strange, right? So that's kind of how it needs to be, guys, right? For it to be, there's every character needs to have a matching one on the other side, right? That's in the exact same position that it is, right? Okay. So yeah. So how do we go ahead and solve it, guys, right? We've done prompts similar to that in the past where we solve a palindrome, guys, right? So as you guys can see, the way we were talking about it right now, we need to check, right? It kind of, you know, um, screams that we should use some sort of a couple pointers, right? Two-pointer technique, to be exact, right? It's going to help us to solve this, guys, right? So we know we have a one at the beginning and one at the end, right? And then we can check, right? Is it a palindrome? It is. Then we go ahead to the next ones, right? And keep checking and keep going in, right? With our pointers, guys, right? So there's a left at the beginning and a right at the end, right? And then we keep checking every pair, right? This one matches this one, cool. Then we go to the next one, right? So the right pointer is here, the left pointer is there. Keeps checking, so on and so forth, right? So let's go through example so it can make even more sense, right? The deletion cases, right? So this is a very simple palindrome, known palindrome, right? So let's say we have this one, right? So we check AA palindrome. We check AA is the match, right? Then we check B and C is not a match, right? That's kind of odd, right? So what do we do in those cases, right? So we can remove one character, right? So we just say remove B, then we're left with ACA, right? Just like if we were to remove C, right? We were left with BA, right? So this is a very good example, right? So let's get the cases where it's even better, right? So you see we have A, B, C, C, A, right? So we check those two things, right? Match, then we move the pointers for inwards, right? Then we check the C and this B, right? Is it a match, right? No, it's not a match. Then we what we need to do in those cases, right, is that we need to remove, try the two scenarios that we can do, right? Either we remove this B and we remove this C, right? And see if by removing those, say we try the first scenario, remove B, right? Is the rest of the string, is it a palindrome, right? If it is, then we simply return, say, if we were to remove B, the string will be a palindrome, okay? Yeah. So that's how the algorithm will work, right? And we simply just for each string, right? For each string, we check, right? And then once we encounter a conflict, we check every character with a pair, right? We check if they're a match. If they're a match, we keep going inwards. And if we encounter a conflict, right? Like this example, right? Well, we have B and C, right? We're like, all right, let's remove B, right? And then we would check the remainder of the string, right? We say remove B, right? This is the string that the range that we're only need to check, right? Because we already checked NA. We know those things outside of this boundary, right? That's outside of the left and right boundary, right? We know that those characters are fine, right? We're only worried about the characters that are between left and right, right? And that's what we need to do. So let's say remove B. So the rest of the string would be C and C, right? And then we check C and C palindrome. Then yes, we return true, right? And we also check, we remove the character at C, is the right pointer as well, right? And we check is B, C a palindrome. This will return false because it's not palindrome, right? Yeah, so and then now, so you can see we're removing B, we end up with A, C, C, A, right? And then which is a palindrome because every character has a match, right? And it makes sense. So hopefully it makes sense to you guys. Let's quickly get into the code. I think it'll make a lot more sense as well, guys, right? So we're going to have the 2-pointer things that we mentioned, and then we're going to have a right pointer. Okay. And then we have a while loop, while the left pointer, the left and the right. And then I told you guys, we're going to increment them inwards, just like we did in the other palindrome problem, guys, right? If you haven't seen it, I highly suggest you go check it out. So if the character, right? What's going on today? Okay. Character at the left does not match the character at the right. Normally we return false right here, guys, right? To say that it's not a palindrome, okay? But this time we're gonna, do a couple things where we're gonna delete one of the characters, okay? So how are we gonna, and then keep checking the remainder of the string is a palindrome or not, right? So we're gonna introduce another function that's gonna check if the remaining string is a palindrome, right? And we're also gonna pass in some boundaries as well. Remember, we only care about the characters that are within the right and left boundary, right? Because everything before left or after right, right? We already checked those characters, right? So we don't need to recheck them again, right? Okay. So we're gonna keep it, all of them, right? All of it. Um, they need to be revisited, right? So we're gonna do the same thing here, guys, right? So yeah, so now let's say we want to remove the character, right, that the left pointer is pointing at, right? Where we have the conflict, right? We remove it, we just say, all right, we skip this character and check if the rest of the string is a palindrome, right? I say, okay, we want to also remove the character at the right, right? And check if we were to remove that, is the rest of the string a palindrome, guys, right? And almost there. What we need to do is write our is a palindrome function, right? And pass in the right, right? So we don't need that anymore because it already has this boundary. Okay. Okay. What happens up on the right? Then it checks if it encounters another conflict. Then it returns false, guys, right? Because it's not a palindrome. Okay. Otherwise, we're gonna return true. Right? If we encounter another conflict, right? Everything matched perfectly. we would just return right away, guys, right? Hey, I think we got everything correct, guys. We check if every, check get the strings palindrome, right? For every character we check, is there a pair of the right pointer, right? For the left and right. If they match, then we keep incrementing and keep going inwards, just like we do with the other algorithm that we have. And then as soon as we encounter conflict, right, a mismatch, we check, we do the simulation where we remove the character at the left or remove the character at the right and check if the remainder of the string, right, and we pass in those boundaries so that we only check those characters within those boundaries, right, not the ones that are already seen and that they've already matched already, right? We don't care about those. First one code, one thing we got to do, return true, submit. Awesome, guys. We're past all these test cases, guys. If you guys found value, you guys understood the thought process in the comment section. If you're new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.